good morning. Welcome back to the session. I'm Dr. C. Raghavendra, Associate Professor, Information Technology, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about a very important concept in computer networks. It's one of the support of network models. It's ISO-OSI reference model. This ISO-OSI reference model is ISO. Everybody knows that even a layman can able to when heard this ISO, they can easily say that it's a one of the standard. It's represent that. So whenever ISO mark is there, that means the particular product is good product. So everybody knows that one. So then why we are giving this ISO is for this OSI reference model means. So here, so in the last class we have discussed TCP/IP protocol. So in this each and every layer we have given some set of protocols. In the same way, in this OSI reference model, we are using so many different protocols in each and every layer. So whatever the protocols we are using in this particular OSI reference model, all are ISO standardized protocols. So that is the reason. So we are calling this is a ISO OSI reference model. Right? We'll see that. ISO OSI reference model is developed by International Standard Organization ISO, and this OSI introduced in the year late 1970s. First step towards international standardization of protocols used in the various layers, right? So this is the first time. So in OSI itself, so first time they are introducing international standardized protocols. So that is the reason. So earlier they may use some ISO standardized protocols or some are not. So but whereas in OSI especially, so from here onwards they use completely only ISO standardized protocols. Okay, that is the reason. So we are calling this model is ISO OSI reference model because it deals with connecting open system interconnection. OSI means open system interconnection. Okay, so OSI, why we are calling OSI means OSI stands for open system interconnection. What open system interconnection? What it is exactly? That means so this open system that are open for communication with other system. We are using this OSI reference model. Okay, so in that particular system is ready to accept any system, that is ready to communicate with any system. So that is here, ready to open communicating with any other system across the world, and shortly we can call it as OSI model. Clear? It has a 7-layer reference model. This is so where each layer should perform well-defined functions. Okay, that means so we have 7 layers. Each and every layer should perform well-defined functions. That means each and every protocol we are using and whatever the functionalities of each layer, all are unique functionalities and perform their own operations by its own and its well. And these functions of each layer should be chosen with internationally standardized protocols. Right? That means so each and every layer it's completely built with the internationally standardized protocols, and the layer boundaries. See, this is important. Please remember the layer boundaries should be chosen in minimize the information flow across the interface. Okay, that means so through OSI reference model, the information is going to be transferred from one system to another system. So here, this layer boundary is going to, why we are choosing this layer boundary system is nothing but here it is the main purpose. What is the main function of this layer boundary, sir? It is just going to minimize the information flow. Okay, it minimizes the information flow across the interfaces. That means so two systems are assume that. Okay, so there are two systems are interconnected. Okay, now we are transferring the data from one system to another system, so where it has a one interface. Okay, and so this is going to be just going to minimize the information flow. That means so it should not be like a very fast or it should not be like a very slow. Okay, so it just minimizes the information flow. If it will be very fast, it is going to be control the flow, and it is transmit to the destination system. Okay, to minimize the flow of information, so this layer boundary system plays a very important role. We will see into the picture. And the layers starts from bottom. Okay, so in the TCP IP reference protocol shoot, so however the layers start from the bottom to top, and the same way here also the layers is started from bottom. And OSI model, if itself, OSI model is itself not a network architecture. Okay, so this is very important. Sometimes they will ask you like so why this OSI reference model is not called as an architecture. Okay, so that is very important. Even for gate also we'll get such a type of questions. Okay, why? Because see, one general basic information is so what is architecture, what is reference model. So in the architecture, what will happen? Always one important thing is in architecture, always it is try to explain a same type of functionality as going to be exhibited in the architecture. But whereas in the reference model, what will happen? So we are using a various different kinds of protocols, and each and every protocol operation is completely different. Okay, and each and every layer having its own functionalities. So that here we couldn't expect always the same thing is going to be happen here. So that is the reason. So OSI reference model is not an architecture, because it does not specify exact service. So when we say that, when we consider any type of architecture, it provide specifies the exact service, but here it is not going to provide exact service. We have a different protocols and different layers are there, different functionalities are there. Okay, and protocols to be used in each layer, so each and every layer we are using different protocols. We are not using the same protocol in all layers, isn't it? All layers have a different functionalities and different protocols we are using. Each layer has been published as a separate international standard, right? Each layer has been published as a separate international standard. This is an example OSI layers. Okay, so I said no, this is a bottom up approach. That's why here first layer, second, third, fourth, fifth, sixth and seventh, right? Total 7 layers. Okay, and so here user. Okay, this is application layer is a user interface layer. One thing you need to remember, application layer is a user interface layer. So that's why here sender is, that means so user is going to send any data from one system to another system like this. In this way it is going to be coming here. So when information is receiving from other system to this user, then receiving coming like this, right? And one important thing is, here we have a 7 layers, and we have to remember these 7 layers in the same order, and we should not exchange, or we should not just replace the order. Okay, and first layer called as physical layer. Next is the data link layer, network layer, and transport layer, session layer, presentation layer, application layer. Okay, so these are very 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 important. Okay, and everyone have to remember all the list of 7 layers. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and finally application layer. And here the bottom 3 layers, okay, the last bottom 3 layers we can call it as hardware layers. Okay, and the top 3 layers we can call it as software layers, and the first in the middle, that is fourth one, transport layer, we can call it as heart of OSI, right? Heart of OSI. So why we are calling hardware layers and software layers means, so here the hardware, see, always when two systems are interconnected means, how the systems are interconnected in generally we already discussed. So how the systems are interconnected in the network, so maybe a wired or wireless, isn't it? So if it is a wired connection means there is some cables are connected. If it is a wireless means there is some sort of wireless devices are going to be added here. Okay, so that's the reason the bottom three layers are linked with this hardware devices. So that is the reason. So these three are hardware. We can call it as hardware layers, and the top three layer application, presentation, and session layers we can call it as software layers. So because those are user interface layers, no. So application layer is completely user interface layers, and the next two layers also the impact will be the high in the here also. So that is the reason we are calling these are software layers, and this transportation is plays a very important role, isn't it? So whatever we are studying, whatever we are doing, all the things, so whatever the protocols we are using, so everything just for the sake of communication, isn't it? Transmit the information from one system to another system, or receiving the information from one system to another system. So that is the reason transport layer is a heart of OSI reference model, right? So we will discuss each and every layer in detail. So this is another type of representation, like here the host A, and this is host A, and this is host B. Okay, so here the same, I mean, so sender side whatever the layers will be there, at the same time receiver side also same layers will be there. Okay, same physical layer, data link layer, network layer, transport, session, presentation, and application layers. So coming from bottom up approach, that is 1 2 3 4 5 6 7 and 7, right? So at the same time whatever the layers in the left side having host A side, and the same layers will be available in host B side. And one important thing here is, see, if you observe here this last phase, that is a data unit exchange. That means so in 7 layers data can be represented in different formats. Okay, so how we are going to represent the data in different layers? So in physical layer we can call the data in bits. That means so all the data is going to be transferred from one layer to, I mean, one system to another system in the form of bits. Okay, whereas in data link layer, so data bits are some group of bits are combined, we can call it as frames, right? Some group of bits we can call it as frames. And in data link layer data can be represented in the form of frames. Clear? Next, here, so in network layer data will be travel from one system to another system in the form of packets. What is packet? So last before class itself we discussed what is packet, isn't it? So what is packet? Packet is nothing but some set of frames. Some set of frames, we can call it as one data packet, right? So the data packet representation in network layer. Then what about transport layer? In transport layer we can call it as transport layer PDU, TPDU, we can say that. So it's a packet data unit. Okay, and here we can also call it as a segment. Okay, data segment also we can call it as data segment here. Okay, and here from session layer onwards we can call it as data packet unit of session layer, and presentation layer data unit, and application layer data unit. Okay, so like this we can call it in the each layer how we are going to we can call it as data. Okay, so we can say that data is in general, formally we can prefer the data, but whereas in the layers so how we have to pronounce data can be represented in each and every layer means like this. So if it is a physical layer, bits, frames, packets, segments, data units here. Okay, and one more important here, this is the subnet boundary. Okay, so in subnet boundary only these hardware layers having this subnet boundary. So why we are calling subnet boundary for only these hardware layer means the data can be transferred through hardware layers only. So that is the reason for these 3 layers we are constructed one subnet boundary. Okay, so what is the purpose of communication subnet boundary? Just for to minimize the information flow. Okay, to minimize the information flow from source to destination system. That is the purpose. Clear? You can found that one terminology called router. Okay, what is router? A router is also a communication device which is going to be transfer the data packets from one system to another system. That means across the internet it is going to just give the directions to reach to the destination. Clear? That means so from source to destination. Okay, and this is called internet. Okay, so from source to destination, like this data is going to transfer. What will happen here? So in the here we have a multiple routes, right? We have a multiple routes up there. So the router is going to give the direction. That means in the data packet having the source and destination addresses. So based on the destination address, the router will uh, gives the direction in which way uh, the particular packet need to travel. That direction is going to be given by this router. Okay. So based on this, it is going to be the data packets are going to be traveled in the internet, right? Subnet. Okay, so we'll see what is subnet, right? So organizations will use a subnet to subdivide large networks into smaller. Clear? Organization will use this subnet to subdivide large networks into smaller, more efficient subnetworks. Clear? So always this is a very general and successful principle. Okay, so whenever so even when we are going to solve any a complex problem, before going to what we are going to do, we just cut down the problem and we just make it into small tasks, okay, or modules, and then we can solve the each and every module, and finally we are going to just integrate the solutions of each and every module, and we can get the final solution. In the same way, so how the organizations are also going to implement the same principle here. So here the subnet, so subdivide the large networks. Okay, so when we are going to handle the large networks, it requires more amount of cost. Maintenance is also very high, complexity is also very high. So when we are going to divide this large network into smaller, so then easy to maintain and more efficiently the network is also going to perform in the uh, transmissions, right? Primary goal of subnet is to split the large network into grouping of small networks and interconnected networks to help minimize the traffic. Okay, so whenever the group of network a complex or a very large network is going to be divided into small networks, and what will happen, so easily identify in which particular network is very busy, or having a more traffic is going to be happen in one particular which particular network, that can be identified, and easily the router can identify which networks are very free, which networks are very complex, which networks having a heavy data traffic. So these things can be identified by the router, and the router is going to change the traffic, I mean data traffic. See, it is very similar to our city traffic. So what will happen, just think that, so here, okay, so here there is a like this some different routes are there. Okay, so what happen if the route is going to be here in this way, the route is completely blocked. That means heavy traffic is there. So automatically what the traffic constables are going to do, so they are going to divert the traffic into the another direction. Okay, so what will happen at the time, the time consumption is going to be taking place, and the because here each and every data packet have a lifetime. Okay, that means within the set of time or within the given time, the packet has to reach to the destination. If the traffic is heavy in this particular some networks, if it's going to be wait for a long time in the queue. Okay, that time, due to timeout errors, the particular data packet is going to be lost. So for this reason, what will happen? The sender have to resend the same data packets again and again into the network. So with this, the network load is going to be increased. Whenever network load is going to be increased, network efficiency is going to be decreased. Okay, the performance is going to be decreased. So that is the reason when we are going to divide a large network into small piece of networks, that is easy to maintain and easy to control the traffic too, right? This way, traffic doesn't have to flow through unnecessary routes, increase network speed, isn't it? So with this, what will happen? So no need to travel unnecessary routes. So it is just going to give the proper direction in which is the shortest path to reach the destination, right? So with this, we can increase the network speed too, right? The first layer we can call it as a physical layer. Okay, in OSI reference model, the first layer is physical layer. The main purpose of the physical layer is transmitting raw bits over a communication channel, right? The main purpose of this layer is transmitting raw bits over a communication channel. So we already discussed in the diagram. So in the first layer called physical layer, the data can be represented in physical layer is in the form of bits, right? So the same thing, the raw bits are going to be transfer from source system to destination system through communication channel. What is communication channel? A communication channel may be a wired or wireless. Clear? Again, in the wired communication channel, again we have some types are there, isn't it? So like cables, different types of cables are available. Okay, so those things is a different concept we will discuss later, right? It deals with mechanical, electrical, and physical transmission medium which lies below the physical layer, right? So the physical layer is going to be directly deal with the mechanical, electrical, and physical transmission medium which lies the below physical layer. See, if you observe this diagram, okay. So here what will happen? So this is a physical layer and this is a physical layer. So like this, there is a connection is there from one system to another system. So all these. So what is this link? This link indicates physical cables or connections. Okay, here data can be represented in the form of bits. Clear? So we already know well. Okay, synchronization of bits. So how the bits are going to be synchronized here, and so in the next level, what will happen? So the data is going to be grouped. Again, when coming to the physical layer, when it reaches to the physical layer, so all these group of packets or frames are going to be combined here. Okay, so how it's going to be synchronized? So those things are going to be handled by this physical layer itself only. And next is the physical topology. So we already have a very good knowledge in topology. We already discussed about what are the various topologies are available. Okay, and though, for example, star, ring, bus. Okay, mesh network, mesh topology. So those are the some examples. Okay, so these are also coming under this physical layer. Why? Because whenever a connection related from one system to another system, all these things will be comes under physical layer only, because the physical layer is a bottom layer and this is directly connected to one system to another system, right? And next is the transmission mode in physical layer. How the transmission mode in physical layer means simplex, half duplex, and full duplex. There are three types. So we are well aware of these three types of transmission modes. Okay, so what is simplex? We just go briefly. Simplex, half duplex, and full duplex. So simplex is nothing but, so this is a one-way communication. That means, for example, FM. Okay. So when we open an FM radio, what will happen? Only we can able to hear the voice of FM different channels, isn't it? We cannot able to talk with them with the radio, isn't it? So this is the example for simplex. Whereas in half duplex, the best example is walkie-talkie. So the police, security people are using now. So only one person can able to talk at a time. Okay. So simultaneously, one after another, we can able to talk. So and full duplex, mobile phones. Okay. So even two people are communicating and both can able to talk at a time. There is no distractions and collision won't occur in this mobile phone while talking. So that is a best example for full duplex mode, right? And So we already knows this one. So layer 1 to 3 or hardware layers, those will network support layers, we can also call it as network support layers. And layer 4 is the heart of the OSI reference model, which ensure end to end reliable data transmission, because the layer 4 is called transport layer, right? Transport layer is the heart of the OSI reference model, and it is going to responsible for reliable data transmission. What is reliable data transmission? Reliable data transmission means, so the whatever the data sender is sent, the same data is going to received by the recipient, isn't it? So that is the reliable. Okay, so when sender will send xyz, okay, so the same, the data has to received by the recipient also received xyz. So instead of if they received axyz, means what will happen? Is this reliable? It's absolutely not reliable. The same data has to receive, then only we can say that it's a reliable, right? Then last 5 6 7 layers, okay, those are the, we can say that software support layers, no, software layers. So those are user support layers. Those software layers are user support layers, because those are user interface layers, very close to user. That's why we can call it as user interface layer. See, this is the example. So here we have some 7 layers are there, assume that. Okay, this is 1 to 7, and here also 1 to 7 layers, and this is a source and this is destination. Okay, so through physical layer, okay, after that there is a bottom transmission medium is there. Through this transmission medium, the data is going to be transferred from source to destination, right? Like this the data will be transferred. Clear? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.